Hi, this is Mrs. Ziegler, and I'm going to go through your final review notes, and this will be everything from Unit 1 through 4 that will be on your final. So you're going to use this to help you fill in your notes here, and then to prepare you for your final. So you should know that you have your variables, which are the symbols for your units, and then your SI unit, which are the main units for that refers to that particular measurement or variable. So remember the number and then the unit. So for example, you have time, which is lowercase t, and then the unit is seconds. So the abbreviation is small s. Okay, so I'm just going to quickly kind of identify the different information. So D again is for distance, H is for height, but they mean the same thing. Meters is our SI unit. Again, lowercase m is meter. The reason why I'm stressing the capitalization of it is because capital M actually means something different. So please make sure that you are writing this information the way it is, because that is what you need to know when recognizing the different units. So you have speed and velocity, which is meters per second. Acceleration, the lowercase a, is meters per second squared or meters per second per second. V, lowercase I, subscript I, is initial velocity, which again, of course, is meters per second. Final velocity, which is V, subscript F, is meters per second. And then G, which is gravitational acceleration, which we know is 9.8 meters per second squared or meters per second per second. All right, force. F, capital F, which is newtons, capital N, and then weight, which is F of G, which is really gravity force, which also is units of newtons. Mass, lowercase m, which is not the unit, but the variable, meaning mass, which is kilograms, kg. Capital W is work, not weight, because F of G is weight. And then, again, units is joules. Capital E, energy, which can be KE or PE, which is potential or kinetic, which also have the units of joule. Then frequency, which is lowercase f, because capital F, of course, is force. Frequency's units is hertz. And then the upside down Y, which is actually called lambda, stands for wavelength, which again is a length, which is a distance, which is meters. All right. Your unit 2 motion calculation formula. So remember, we can see here that there's other units for distance that you need to be able to recognize. But again, the SI unit, the ones that you'll see the most will be meters. But there's miles, inches, yards, centimeters, millimeters. Then you've got your units for velocity, which is always the units of distance over time. So miles per hour, which miles is just MI, the abbreviation, not M. M/S, remember, is meters per second. Inches per second, yard per minute. Any distance unit can be miles per second, can be a unit of velocity. These are the different variations of formulas that you need to know. Again, on your final day, you will get an actual equation sheet, but will only have the base formulas such as these. Okay, I have given you here to write out the other formulas, the rearranging of those formulas. All right, so now we're just going to review Unit 1. So Unit 1, so remember relative motion, you need to know the definition of that. You need to know the difference between distance, which is the length of path between 2 points, or how far it is from one point to another. Displacement is the distance and direction of that object motion from its starting point. Okay, so if my starting point and my ending point are the same, that is the reason why displacement is 0. If you have your vectors, which again, vectors are something with numbers and a direction, when they are in the same direction, you're going to add them. Okay, so therefore 3 to the left plus 5 to the left will make it 8 to the left. Okay, whereas when they're in different directions, 5 north and 6 north, we're going to subtract them. And so the overall displacement would be the bigger of the two directions. So it would be 1 south. And again, the magnitude would be like if it was yards or centimeters, whatever the distance is. Okay, so now looking at this is a person walks 2 blocks east, then 1 block north, and then 2 blocks west. So again, we're going to add these up to get our distance. So 2 blocks plus 1 block, and 2 blocks would be 5 blocks, but then we have to figure out the displacement. So again, if we drew it, it's 2 blocks to the east, 1 block to the north, and then 2 blocks to the west. So therefore, my displacement would really only be 1 block north. Okay, so again, that's how you can figure out what your displacement is how far they are from the starting point in what direction. Speed, remember, is the distance an object moves over the amount of time. So it's essentially how fast that object is moving, where velocity is the speed and direction. So how fast and the direction that object is moving. Instantaneous speed, we need to know how to read a graph and what the slope of a distance time graph looks like. When it looks like that, we know that it is constant speed. Okay, so acceleration is the rate of change in velocity. There's 3 ways that an object can accelerate. So remember, it can accelerate by speeding up, slowing down, or changing direction. All right, so now looking at the graph, again, you should be able to look at the different graphs and explain what kind of motion is happening. If it is a straight line with a positive slope, that means it's constant speed going forward. If it is a straight line going down with negative slope, that means it's moving backwards. If it's a flat line like this, that means that there's no motion, it's at rest. If it's a curved line, that means in positive acceleration. If it is a curved line going negative, that's negative acceleration, which essentially is deceleration. All right, so now moving on to unit 2, unit 2B, which is unit conversions. So remember the basic 2 steps is first you need to find the conversions that are needed. Then you're going to set up your T-chart. So again, if I have going 350 meters to kilometers, the conversion you first need is the conversion from meters to kilometers, which on your sheet you will see that there's 1,000 meters in 1 kilometer. To set up our T-chart, we start with what we've been given. Okay, then we use this unit that is here, and we take that unit, not the number, we take the unit, we put it diagonal, and then what's on top will be equal to it. In this case, it's kilometers. Then once I have my unit set, I put my numbers where the units are, placing the units diagonally. So therefore, 1,000 is with meters, 1 is with kilometers. So therefore, based off of how I have the numbers, it's going to be divided by my meters will cancel out. My meters will cancel out, and then I'm going to divide the number, and kilometers is what's left. Here is units 3 formulas. These are the unit for Newton's second law. Force is equal to mass times acceleration. And then this is the formula for weight, which again, G stands for the the 9.8 meters per second squared. These are the formulas you need to know for energy. We have work, which is force times distance. We have kinetic energy, which is mass times velocity squared divided by 2, which also looks like this. And then you have potential energy, which is actually gravitational potential energy, which is mass times gravitational acceleration times height. And then the last unit that we have math in is our unit 5, which is the one we just finished, which is just velocity is equal to wavelength times frequency. And then you have the other 2 formulas that you have to rearrange solving for frequency and wavelength. All right, moving to unit 2. All right, unit 2, you need to know what forces are, the definitions of forces. You need to know the difference between balanced and unbalanced forces. Remember, balanced forces are when the forces are equal and opposite and they cancel each other out. Where unbalanced forces means that there is an overall net force, meaning object moves. Again, with calculating net force is the same the way that we calculated for displacement. So if you have vectors that are opposite, meaning that they're going away from each other, this is a pulling force. When they're going into each other, that's a pushing force. So these forces, since they're equal and opposite, all right, these are balanced forces because both of these have, when I subtract them out, are 0 net force. Whereas these forces, you can see, are unbalanced because this one is bigger than this one. So therefore, it's 4 newtons to the right minus 1 newtons to the left, so therefore it's 3 newtons to the right. These are in the same direction, so therefore 3 newtons to the left, 1 newtons to the left. Add them together, it's 4 newtons to the left. That's how we calculate net force. And then on top of knowing that, we need to know the 6 different forces: tension, spring, applied, gravity, normal, and friction. You need to know the definition of those, and you need to know how to draw the different free body diagrams. For this unit, we also have Newton's laws. So Newton's laws, again, we have Newton's first law, which is every object stays in motion. Any object in motion stays in motion. An object at rest stays at rest unless the net force acts upon it, which is called the law of inertia. Then you have Newton's second law, which is a net force causes mass to accelerate, which is also called the law of acceleration, where the formula is force is equal to mass times acceleration, where we also have weight. And then we have Newton's third law, which is for every action, there is an equal and opposite reaction, which is called the law of reactions. Unit 4 starts energy. So again, you need to know the difference between kinetic, which is energy in motion and all the different types. And then you've got potential energy, which is stored energy, and then these different types. So those are the notes that you will use. I'm not giving you condensed notes for waves since we just finished that. So therefore, this is what you'll use in order to help you complete your fill-in notes for your final.